Okay, welcome back, Algebra 2 students. So, in this video, we're going to go over section 2.3, solving linear systems using technology. And by technology, that means our TI-84 calculators. So, you'll need that for this to do this lesson, but before we move on to that, first we got to know how our calculators actually interpret a system of equations, and so we have to be able to write a system of equations as a matrix. So, let's see, starting off with this example here. For a matrix, what we're going to do is we're going to put our matrices in these rectangular brackets. And what they're going to do is in each column, we're going to have x's, y's, z's. We'll have this vertical bar, and then we'll have constants, which I'm going to represent with a C. And this is going to be called an augmented matrix. And so this is how your calculator is going to interpret uh, your systems of equations. You're not actually going to write like the x and the plus and the y minus z equals. You're actually just going to write off the coefficients of each of these variables and then the constants at the end. So if we wanted to write this system of equations as a matrix, in the first equation we have 13x, then we have 6y, and then we have negative 20z is equal to 60. And that would be our first equation represented as a matrix. The second equation, notice that we don't have any x's, so we would write this as a 0. But then we have negative 6y's, then we have negative 7z's, and then we have negative 50 as our constant. Next we have negative 18, we have negative 16 for y, we have 4 for z, and we have 0 as our constants. And it turns out that you don't actually need those x, y's, and z's for the c. So I'll erase that just so you can see what answer I'm looking for each of these. It'll be understood that each of these represents x, y, z, and then your constants. And so this is what your system of equations would look like as an augmented matrix. And so that's number one. Number two is very similar. I'm going to set up some brackets. I know I'll have my x's, my y's, my z's. I'll put this vertical bar where our equal sign would go. And then we'll have this other closing bracket for our constants, and they'll go here. So looking at the first equation, we have 8x. We have no y's here, so we'd put a 0. And then for the z's, we have a 14. And then that's equal to negative 24. For the second equation, we have 16. We have negative 8 for the y's. We have 14 for the z's. And then we have is equal to negative 64. In the last equation, we have 4, negative 9, 5, and 80. And so this is our our example number 3, written as an augmented matrix. For number 5, we go a little bit faster. Just reading off the top, we have 4, 8, 12, and then 48. So so we have 4x, 8y, 12z is equal to 48. For the second equation, we have 11x, negative 17y, 9z equal to negative 99. And then for the last equation, we have negative 4x, 7y. We're missing a z, so we put a 0, and then that's equal to 63. And for number 7, we have 4x, negative 4y, no z's, so we have a placeholder 0, is equal to 36. For the second equation, we have negative 7x, negative 20y, negative 18z is equal to negative 9. And then for the bottom equation, we have negative 2, negative 10y, 19z is equal to 87. So this is each of the examples for the first page, all converted from a system of equations into augmented matrices. So now that we know how to write each of these systems as an augmented matrix, we need to know how to actually solve systems of equations using our graphing calculator. So now we're going to go over to the next page. And just like before, we're going to solve these systems of equations, but you have a lot less space to actually do these. In fact, these problems are going to be harder than they were for when we were solving these by substitution and elimination. Notice these numbers are a lot bigger, and they're going to be less convenient as a result to actually solve by hand. So if we were doing these by hand, they'd just be longer, more computation and intensive. They wouldn't be as fun to do. But with our graphing calculator, these are actually going to be really, really easy because our graphing calculator is going to do all of the heavy lifting for actually solving these. All you have to do is just put them in your graphing calculator. So I have mine here. And what I'm going to do is, since we're not going to need to look at the evens, I'll just keep my calculator there. First, what we're going to want to do is when you turn on your graphing calculator, make sure you hit second mode just to quit back to this home screen. And I'll use a red pen so you can see more easily where I'm pointing on my calculator. But the first thing that we're going to do is we're going to go to second and then hit this x to the negative 1. That's going to activate the matrix functionality. And we're going to have three options. We have names, math, and then edit. If your calculator, if you haven't done this before, all of these, it'll just say A, B, C, blah, blah, blah. But we're going to scroll over to edit. And you can pick any of these matrices, but usually we're just going to pick A. Next, we need to define the matrix dimensions. So if we go back to this first page for a second, we got to know what the dimensions of each of these matrices are. And notice that we have 3 rows, so 1, 2, 3, by 4 columns, 1, 2, 3, 4. So 3 rows, 1, 2, 3, by 4 columns, 1, 2, 3, 4. And so all of your matrix dimensions, dimensions are equal to the number of rows that you have by the number of columns that you have. So we have 3 rows by 4 columns, and so in this case, this is going to be a 3 by 4 matrix that we're looking at for number 1. And it turns out that for each of these, they're all going to be 3 by 4 because this whole chapter so far, we've been working with three equations three equations with three variables. And so three equations with three variables means that we have, well, three variables. So that means that we're going to have at least three rows there, but then they're always equal to a number. And that last number that they're always equal to, that constant, is going to be that final column. So they're all going to be 3 by 4. So when we go back to this page here, and we're looking at the dimensions for our matrices, we're going to hit 3, and then I know you can't really see that on my end, but I hit 3, and then I hit enter, and then I hit 4, enter, and now look at that. We have a matrix that looks pretty similar to the size that what we were looking at just now. The next part is that we're just going to manually enter each of these numbers. First, let's represent this as an augmented matrix. So we can write this first one as -3, -20, -10, and then 56 for the top row. Then we have -3x, 2y, no z's, -28. And then we have -3, 3, 6, and -54. So now we're going to do that in our calculator. Now your calculator won't have that vertical bar right here, and you really don't need it. It's more of just it's a visual separator for us, for humans to look at, just so that we know that, okay, that's where our equal sign is. But you really don't need to write the vertical bar. It's more of just a visual aid. So your calculator does not care about having a vertical bar there or not. All it wants is for you to put the -3. And when you're typing in a negative, remember that this is your negative button. So whenever you want to type in a negative, you always hit this button, not subtraction. That's a very common mistake for students. So we're going to make sure that we put -3, and then we'll put -20. By the way, notice that the negative is shorter and it's higher versus if I put -20. So that's how you can tell visually on your calculator whether you put negative or minus. The negative is shorter than the minuses, and it's higher than the midline of the line that you're typing on. So I'm going to delete that. Of course, we can do delete, delete, delete. But now we have -20. Then we have -10. And every time you hit enter, it's just going to go like from left to right as if you're reading. So left to right, down a line, left to right, down a line, left to right. And so I recommend getting used to just typing these in like that. But we have 56, and then when I hit enter, it went to this next one right here. That's going to be our -3, 2, 0, -28, -3, 3, 6, and then -54. So once we finish typing all of our entries into each of these little spots, we're going to quit out of this. We're going to do second and then mode. And now we're back to this home screen. So we finished filling out our matrix. The next part of this is to do second, and then we're going to hit this little X to the -1 again. And now notice your calculator remembers what you put in when you edited this. So if I go back to this and I hit enter, I can go back to editing this. So I'm going to quit out of that. So when I go to second and then matrix, it remembers this. Now we want to perform an operation on this. We're going to scroll over to math, and we're going to scroll all the way down until we find RREF. We're going to hit enter, and then we're going to do second matrix, and now we're going to refer to matrix A, the one that we were editing, by its name, and when you hit enter, your calculator is going to perform some operation, RREF, on A. Now, you're technically supposed to close off this with parentheses, but your calculator actually doesn't care if you do that. So if you just hit, after you enter on A, if you hit enter again, it'll actually just do it. It doesn't even give you a syntax error or anything. But now this is your answer. So what the heck? Why is it? How do we interpret this? Well, remember, this meant negative 3x minus 20y minus 10z is equal to 56. If we think about what this first row is saying, that first row is basically saying that 1x plus 0y plus 0z is equal to 8. Which really just means, because we really don't need 0y and 0z, it really just means x is equal to 8. That middle row means 0x plus 1y plus 0z is equal to negative 2. Which really just means, because you don't need 0x and 0z, and you don't even need that 1 either, that just means that y is equal to negative 2. And for the last row, you have 0x plus 0y plus 1z is equal to negative 4. And that means that, because you don't need 0x and 0y, that z is equal to just negative 4. And so, really, just like before, if we know that x is equal to negative 8, y is equal to negative 2, and z is equal to negative 4, we can piece that together into a single statement, and we can write that as x, comma y, comma z is equal to 8, comma negative 2, comma negative 4. And so that would be your final answer right there. So your calculator took this augmented matrix, and with RREF, whatever that stands for a second, I'll tell you in a minute, it did some operation, and it converted it into this new matrix, and it's able to list off our answer. So what that stands for, by the way, RREF, I'm going to write that up here or on a blank sheet of paper. I'm just getting a little cramped on that one. But RREF stands for row reduced echelon form. And all echelon form really means is that it changes your matrix in such a way that an echelon is basically just like, you can kind of think of like a troop, like a soldier arrangement, and it basically just makes all of these what we call leading ones. We have zeros, and the row reduced part is just ensuring that we have like this diagonal of ones, the rest of these are zeros, and that we have numbers here. And so that's going to be our solution. It looks like this. This is really just telling us x, comma y, comma z is equal to whatever these three numbers are, a, b, and c. But an echelon is kind of like a tier or an arrangement. Sometimes, like in the military, you have planes or soldiers that are arranged in like a triangular format, and basically the echelon here, the triangle is visualizing it kind of like that, and so it's kind of like a troop arrangement. But that's not too important. It's just to give you an idea of why it's called row reduced echelon form. Echelon because it forms kind of like a triangle, and then particularly we want these ones here, and the row reduced part means that it makes just a diagonal of ones and then zeros here. But I'm not going to get into like exactly, at least in this video, how your calculator actually goes from the original matrix that we had into this form. Maybe in a different video, but for now, all we care about doing is trusting that your calculator has some kind of way to convert this matrix into the one that we saw in our calculator right here. It's by a method called Gauss-Jordan elimination, or sometimes just Gaussian elimination. But that's beyond what we need to do for this assignment. For now, we're just going to focus on inputting these matrices into your calculator, letting your calculator be a magic little box, and output an answer for you. So if we look at number 11, let's see what we get. First, I'm just going to write this as an augmented matrix, and it doesn't matter what our variables are. So in this case, we have A, B, and C, and so just staying alphabetical, we'll have negative 13, negative 10, 17, and then 30. Let's see, for the second one, we have negative 12, but we don't have B or C, so we have 0 and 0 is equal to negative 72. And then we have negative 17A, negative 6B, 5C, and then negative 58 for our constant. So when we go back into our calculator, let's see, we can clear that. And so now we're going to go and we're going to do second and then matrix. And we can actually go back and edit this old matrix. If I hit enter, it brings us back to this, and you can actually just scroll down. So scrolling down, and it gets back to this first entry that we have here. And what you can do is you can overwrite each of them. So like if I start typing, if I type in negative 13 and I hit enter, it'll overwrite that entry. And then it moves on to the next one. Now it's highlighting negative 20 from the old matrix. If I type negative 10, hit enter, it overwrites it. And if I keep on going, I'll have 17, I'll have 30, I have negative 12, 0, 0, negative 72, negative 17, negative 6, 5, negative 58. And now that I'm done overwriting each of these entries, I can quit out. So I'll do second mode so that I quit out. And then we're going to do RREF, so second matrix, scroll over to math, scroll down to RREF, hit enter, second matrix. And now that we've edited matrix A, we're just going to refer to matrix A by name now. When we hit enter, now we have RREF of A, and when we hit enter, we have our answer. And so that tells us that the answer here is x equals 6, because that means 1x plus 0y plus 0z is equal to 6. We have y is equal to negative 4, and we have z is equal to positive 4. And so our answer here is x comma y comma z is equal to 6 comma negative 4 comma 4. And that is our answer. All right, let's see what happens with number 13. So number 13, I'm going to write as a matrix, and maybe you don't have to do this part at this point, and that's perfectly fine, but I'm going to write this out. We have negative 18a, we have negative 18b. We don't have any z's, or sorry, any c's, so we're going to put 0. And then we have 54. We have negative 6, negative 8, negative 1, negative 81. We have 4 A's. We don't have any B's, but we have negative 2 C's, and that's equal to negative 34. So when we go to put this into our calculator, I'll do second matrix. I'll scroll over to edit, and I'm going to overwrite the old matrix from problem 11, and now I'm going to enter in the new numbers. So I'll scroll down until we get to this first upper left entry here, and I'm going to overwrite each of these. So we have negative 18, negative 18, 0, 54, negative 6, negative 8, negative 1, negative 81, 4, 0, negative 2, negative 34. I've finished overwriting each of these, so I'm going to quit. So I'll do second mode. And now I'll do second matrix, scroll over to math, scroll all the way down until we find RREF, hit enter. And then we have second matrix, refer to A by name, so hit enter. And we get this. What the heck? What's happening here? So this doesn't look like what we were previously dealing with. So let's think about that. So I'm going to write on this blank sheet of paper over here, and let's think about what was what's happening with this answer. So just reading off what this information means, this means that we have 1x, and I'm going to, there we go, that way we only see the matrix that we're talking about for this problem. But that means that we have 1x plus 0y minus 0.5z is equal to 0, which really just means that x minus 0.5z is equal to 0. The second equation is very similar. That one means that we have 0x plus 1y, and then plus 0.5z is equal to 0, which really we don't need 0x. And this is really just y plus 0.5z is equal to 0. So there's nothing inherently wrong with these equations. That's fine. It's when we look at the third equation that we run into trouble. Because what that means is we have 0x plus 0y plus 0z is equal to 1. And really, all of this is just 0 is equal to 1. And so, just like what we saw in the last two videos, this 0 equals 1 condition is false. This is not true. And so, what that means is we have no solution. And so, this is your calculator's way of telling you that you have no solution. It doesn't just say no solution on your screen. It tells you in the form of this bottom equation here that you have 0 plus 0 plus 0 is equal to 1. So when we have 0 is equal to 1, we know that is false. And so for number 13, we have no solution. And there we go. All right, let's look at number 15. If we convert this into a matrix, we have 2 x's, no y's, no z's, but then this is equal to 14. For the second equation, we have negative 5 x's, 4 y's, negative 9 z's is equal to 13. And then we have negative 15 x's, 4 y's, minus 9 z's equal to negative 57. Okay, so that's fine. Let's go through with our calculator steps. Just gonna hit clear so it clears my screen, but I'll hit second matrix, scroll over to edit, and then choosing matrix A, I'll hit enter. I can scroll down to the first entry here, and I'm just going to overwrite each of these with these numbers. I have 2, 0, 0, 14, -5, 4, -9, 13, -15, 4, -9, -57. Now they're all overwritten. Second, matrix, scroll over to math, find RREF, hit enter. Oop, crap. I gotta quit out of that first before I start doing that. Second, matrix, scroll over to math, RREF. Okay, gotta make sure you're back on your home screen before you do that. RREF, second, matrix, A, and now when you hit enter, we get this. So this is very similar to what was happening with the previous one, except now we have something a little bit different. This is telling us that we have x is equal to 7, because we have just x plus 0y plus 0z is equal to 7. The second equation is telling us that y minus 2.25, y minus 2.25 z is equal to 12. Okay, nothing wrong with that. But the bottom equation is telling us that 0x plus 0y plus 0z, which is really just 0, is equal to 0. And so this bottom equation is 0 is equal to 0. And again, if we remember from this chapter so far, anytime we've seen this 0 is equal to 0 statement, this is true, and this means that we have infinitely many solutions. And so anytime you see this bottom row of zeros, that means you have infinitely many solutions. And so when we go back to this question here, we have infinitely many solutions. There we go. So now that we know what each of these looks like, or what kind of solutions we'll see, we'll have a unique solution. And so with the unique solutions, we'll see something like this, where we have this diagonal of ones, and then they're surrounded by these zeros, and the last column is just going to be 3 numbers. Anytime you see that, that means that you do have a unique solution. And in this case, that was, number 11, where we can say that our solution was x is equal to the top number, y is equal to the middle number, and z is equal to the bottom number. When we have a matrix that looks like this, and we see usually some weird numbers that are not ones over in everything but the last column. But if we notice in the bottom row, we have 0, 0, 0, and then a 1. So if you see a bunch of zeros and then a 1 at the very right, that means that you have no solution, because you have 0x plus 0y plus 0z is equal to 1. So in other words, 0 is equal to 1. So you'll have no solution when you see a bottom row like that. And lastly, if you see a bottom row of all zeros, that's going to be true, because you have 0 plus 0 plus 0 is equal to 0. And because 0 is equal to 0, that is true. That's how we'll know that this is infinitely many solutions. So these are the 3 types of solutions that we can expect. So now I'm going to just go through and finish up the last 4 problems, 17, 19, 21, and 23. And just so we can see what each of those is. And for those, I'm going to skip writing each one as a matrix just for sake of time, and I think we should be okay with that skill by now. So if I just go to second, matrix, if I edit, hit enter, and I just want to start overwriting these. So if I look at number 17, I see that we have 9x, we have 1y, we have negative 9z, and then is equal to 39. Notice we don't have any x's, so I'm going to put a 0. Then we have negative 2y, 9z, and negative 96. And then for the last equation, we have negative 15x, negative 17y, 19z, and that's equal to negative 21. So let's see what we get. We're going to quit out, second, matrix, math, scroll all the way down to RREF, enter, second, matrix, enter, enter, and there we go. So for this one, that means that we have x comma y comma z is equal to negative 7, negative 6, and negative 12. And that's all we have for number 17. Let's look at number 19. So I'll just clear my screen. Second, matrix, scroll over to edit, scroll down to the first entry. For number 19, we have A, B, and C. We have 0A, we have 11B, and we have 1C is equal to 38. We have 3A, 12B, 6C is equal to 75. And then we have negative 4A, negative 16B, negative 8C is equal to negative 100. All right, we're going to do second. Oh, gotta quit out. Second, matrix, scroll over to math, scroll down to RREF, second, matrix, enter, enter. And this one has funky numbers, but notice that we have that bottom row of zeros, and so it is infinitely many solutions. And there we go. All right, let's look at number 21. So I'm going to clear my screen. Second, matrix, scroll over to edit, enter, scroll down to the first entry. We have negative 2, 17, 18, 2. Next equation, we have 0x. We have negative 16y, negative 19z is equal to 7. And then for the bottom equation, we have negative 15x, negative 5y, negative 15z, and that's equal to 95. We finished editing this, we quit out, second mode, and now we're going to do second, matrix, scroll over to math, scroll down to RREF, hit enter, second, matrix, enter, enter, and we have a solution. So we have x comma y comma z is equal to negative 8, negative 4, 3. And there we go. Last one. I'm going to clear my screen. Second, matrix, scroll over to edit, scroll down to the first entry. We have A, B, and C again. We have 0A, we have 12B, and we have negative 16C, and that's equal to 76. And then we have 4A, 4B. We don't have any C's, so it goes 0. And I have 92. And then lastly, we have negative 20A, we have negative 14B, negative 8C, and that's equal to negative 48. Now that we're done entering this second mode so that we quit out, second, matrix, scroll over to math, find RREF, and then second, matrix, enter, enter. And so we see with this one, we have 0, 0, 0. So 0x, 0y, 0z is equal to 1. That means 0 is equal to 1. And so we have no solution. And so that's how we solve these systems of equations using our graphing calculator. What I recommend doing is if you look back at assignments 2.1 and 2.2, you can actually go in and verify each of your solutions using your graphing calculator now. So I recommend going to do that. Just see how fast you can solve stuff now using a graphing calculator versus doing this all by hand. And I think you'll find that the graphing calculator is actually significantly faster and a lot less mentally taxing to do. So anyways, that's all I have for you on this one. So have a good one.